This question is about the constant accelerated motion of a rocket which starts from rest. So it means that its initial vertical velocity is 0 meter per second. So this is a rocket that we we consider it starts from its origin or from the ground, where its initial displacement, its initial position is 0. Okay, and what happens according to the question? It accelerates with 3.2 meter per second square until it runs out of fuel. So how it will rise? Because it's accelerating, that's why it will cover more distance in every interval. So this is a level where it runs out of fuel. Before that, it was moving with constant acceleration, 3.2 meter per second square. And when it runs out of fuel, what happens after that? Now it will move on the basis of its inertia. So it means that now this rocket will not stop at this point, rather, it will move further up because of its inertia, but it will stop at some level that will be its maximum height, and we consider this is a point. So, students, this is the free fall motion. Why is that? Because during this, only one force exerted on it, that is its weight. So during this, acceleration is negative 9.8 meter per second square. So we divide this motion into complete motion into two segments. So the first one is when moving at an acceleration of 3.2 meter per second, and second is when moving under an acceleration due to gravity. So how high it moved with this acceleration 3.2? So according to the question, that is 775 meter. This is the vertical position of the rocket when the fuel ran out. Okay, so our first question, dear students, is about what is the velocity of rocket when it runs out of fuel. It means that we need to find out the velocity at this point. So we will call it Vy. So let us see what data do we have. Do you know the initial position, that is from the origin, from the ground? Do you know the displacement, that is 775 meter? So that's why the delta y is equals to 775 meter displacement covered, as well as we know acceleration. Okay, and we also know about the vertical velocity. Okay, so we will apply kinematics equations. So which equation? We don't know about time, that how much time it took. So we have a right choice if you consider this equation, vy square vy0 square plus 2a delta y. So when you will plug the values here, because this is what we have to find out, so we will take square root, and since it started from rest, so its initial vertical velocity is 0, plus 2 into 3.2 into displacement covered is 775 meter. So the vertical velocity at that point is 70.42 meter per second. That's a lot. Okay, now it didn't stop at this point, rather it moved further high. But as you know that there's a no fuel that is actually consumed by the rocket anymore. That's why now it will fall freely, means that its acceleration due to gravity is negative 9.8 meter per second square. So if we our next question is, how long does it take to reach this point? Which point? At this point. So we will once again use the same data. So which equation should we use? Vy is equals to Vy initial velocity plus acceleration and the time taken. So initial velocity is 0, and that is 70.42 is equals to 0 plus Ay is 3.2, and the time taken is unknown. Let's call it T1. So then the time taken is 22 seconds to cover 775 meters. Okay, let's go to part C. Question number C is, what maximum altitude does the rocket reach? It means that If you now find out this vertical displacement, let's say it is y2, and then if we add into 775, that will be the maximum vertical displacement. Now in this segment of motion, you know very well that acceleration is negative 9.8 meter per second square, whereas it finally stopped at this point where I can say its final velocity, okay, let's say v prime y is equal to 0. All right, now we will consider this velocity, which we calculated 70.42 meter per second as an initial velocity in this part of motion. All right, in this segment of motion, the 70.42 will be considered as the initial velocity, and final velocity is 0. Because if I show you quickly, if for the second segment, the velocity will change like this. This is the velocity time graph. This is 70.42 meter per second. That's why I'm saying it's initial velocity, and this is the 0 meter per second. It's the final velocity. Okay. Now we want to find out y2. So obviously we will once again apply this equation, but we will write it according to our like alphabets. So that is vy prime square is a final velocity, vy is an initial velocity square, plus 2a y, that is actually negative g, into delta y. So, and students, don't forget this delta y is the change in position. All right, so where it is now, if you see, so let's say the maximum height is y3. Okay, so delta y right now is actually y3 minus 775. Okay, right, why? Because I am using this data, this initial velocity and this final velocity, so that's why I am taking this thing, right? Initial position is 775 and final position is y3, maximum height. So if you plug the value, so it is 0 square is equals to 70.42 square plus 2 into negative 9.8 into y3 minus 775. Okay, so taking it to the other side, it will be negative, and opening the square is 495, let's say 59, is equals to negative 19.6 into y3 minus 775. So this gives us 253.01 is equals to y3 minus 775. So you remember what we need to calculate. We want to find out maximum altitude. Does the rocket reach? So it means that this is basically y3 that we want to find out according to my, I mean, designated variable. So the y3 will be equals to 253.01 plus 775. So finally the maximum height is 1028.01 meter, which is almost 1 kilometer. Okay, now our next question is, how much time does it take to reach maximum altitude? Okay students, so to find total time, once again don't forget that it's a two segment motion in which the one acceleration is 3.2, another one acceleration is negative g. So we have to calculate the times in their different segments. So the total time will be equals to, let's say, t1 plus t2. Okay, t1 is during when it was accelerating. Okay, so that will be, actually, why not we can apply this equation once again, this one, to calculate the time. Okay, so during motion when a is equals to 3.2 meter per second square, so dear students, we can apply vy is equals to vy0 plus ay t1, right? That's what we want to find out. So 70.42, you remember, at a height of 775 meter is equals to 0 when it started plus into 3.2 into t1. Oh, we had already calculated, it is 22 seconds. But during free fall, so during free fall motion, dear students, at this point initial velocity is 70.42 meter per second, whereas at this point velocity is 0 meter per second. Acceleration due to gravity is negative 9.8 meter per second square. So let's apply this equation. Vy is equals to Vy0 plus Ay t2, right? So 0 is equals to, so negative 70.42 is equals to negative 9.8 t2. Negative and negative is cancelled out, and our time during free fall motion is 7.18 seconds. So the total time for this, you have to add these two times, so that must be 29.18 seconds. Okay, so this is the total time to reach the maximum height. Okay, but how much time it will take, for this you have to calculate again, but that's is not asked here. Now our next question: with what velocity does it strike the earth, and how long was it in air? Okay, it is asked. So now there are two more questions. So for to calculate with what velocity it hit the ground, now right now it is at its maximum height. You remember how much was that? It was 1028 meter. Okay, anyway, so now we will consider this as the initial velocity of the rocket. If you want to calculate its final velocity when it will hit the ground, just before it hitting the ground, which means that imagine if this is a ground, just before hit the ground, we want to find out in this question right now the final vertical velocity. Okay, so let's say final vertical velocity. Okay, do we have all the variables that required? Yes, it is falling freely, so negative 9.8 meter per second square. Okay, so do you know the vertical displacement, how much it has moved downward? Okay, yeah, we had already calculated, so it should be negative 1028.01 meter. Why it is negative, students? Because it has moved downward. So we can now apply this equation. Vy square, okay, is equals to initial velocity plus 2ay and delta y. So if you want to find the final vertical velocity, so you should take a square root of this. So initially it was at rest because it was its maximum height, plus 2 into negative 9.8, okay, into final position is 0 because it is now at ground, minus initial position is where it was when it was at a height of 1028.01. So from this you can find out the final vertical velocity. So our answer is plus minus 141.94 meter per second. So it cannot be a positive answer because it is moving vertically downward. That's why we must take only this answer acceptable, right? Now a last question but not least, how long was it in air? Okay, well, for this, the grand total, okay, the total time should be equal to sum of t1 plus t2, and let's call t3 is the time when it will take to reach from a maximum height to the ground. Okay, we are calling it t3. We already know t1 and t2. How to calculate t3? Because it's accelerating with a constant value, that's why you can apply this equation. Why not? So final velocity is equals to initial velocity plus acceleration and t3. What's the final velocity? We just calculated, it is negative 141.94 meter per second is equal to 0 meter per second when it was at maximum height, minus 9.8 is the acceleration due to free fall, and t3 is the time that we want to calculate, and t3 will be, so 14.48 seconds is the time that it took to move from this point to this point. So total time that it was in air is 43.66 seconds. So total we have solved 7 questions from in this single question. It was very lengthy, but I hope you understand. So all of these questions we have answered. You can send me an email to request its PDF and other questions also.